So in part B, we have three sets: oceans, bodies of salt water, bodies of fresh water. So we have three sets, and let's see how these three sets are related to one another. So clearly, if we have bodies of salt water, we could have saltwater lakes, oceans, etc. So if this is the set of all bodies of salt water, oceans are a type of uh, bodies of salt water. So all oceans are bodies of salt water. But all bodies of salt water are not oceans, because there could be lakes that are bodies of salt water, because we could have saltwater lakes, and so on. So therefore, the set of all oceans sits inside the set of all bodies of salt water. And that's why we have the first Venn diagram, which is the set of all bodies of salt water containing the set of all oceans. Now, when we look at the set of bodies of fresh water, now clearly, if it's a body of fresh water, it cannot be a body of salt water. So the set fresh water and the set salt water do not overlap, and that's the reason why we have to represent them using non-overlapping circles. Part C, we have teachers, that's one set, swimmers, and tall people. So we have three overlapping sets. All three are overlapping because there could be a person sitting in this overlap of all three circles. So what characteristics will this person have? This person is a teacher, also a swimmer. So we use the word and, a swimmer, and a tall person. So it's a set of three circles all overlapping with one another. The Venn diagram in question 5 represents a set of all people that attended a conference. So this big rectangle is all people who attended the conference. So this is the rectangle we're talking about. It is the set of all people who attended a conference. So the next page, we have a few questions that we're going to answer using the information given in this Venn diagram. So the first question is, how many people at this conference are employed men without a college degree? So our first question, how many employed men, so they have to be employed, they have to be men and without a college degree, which means no college degree. So how many such people do we have? So they have to be employed. Okay, so they have to be sitting in the circle of people who are currently employed. They have to be men, which means they cannot be women. So they have to sit outside of the circle of women, inside the blue circle but outside the red circle, and no college degree, which means they also have to be sitting outside the green circle. So inside the blue circle, outside the red circle, and outside the green circle, the only number that fits the description is 6. So there are 6 people who are employed and men and no college degree. So that answers our question. How many people at the conference are employed men without a college degree? And the answer is 6. So let's look at our next question. How many people at the conference are unemployed women? So let's think about this. So the second question is unemployed, so not currently employed, and they also have to be women. So how many unemployed women do we have at this conference? So first of all, let's think about this. This person has to be a woman for sure, right? So they have to be sitting inside the woman's circle. They also have to be unemployed, right? Which means they have to be sitting outside the currently employed people's circle. So they have to be sitting inside the green circle but outside the red circle. So the only two numbers that fit that description are 4 and 20. So the answer is there are 4 plus 20 people who are unemployed, and women, basically they're unemployed women. So the answer to that question is 24. The next question we need to answer is how many people at the conference are unemployed men without a college degree? So unemployed men. So the men have to be unemployed, okay, which means they have to be sitting outside of the currently employed people's circle. So let's think about what this circle is. So if this is the circle of currently employed people, they have to be sitting outside that circle. They have to be men, which means they have to be sitting outside the red circle. And they cannot have a college degree, which means they have to be sitting outside the black circle. So they cannot be in the red circle, they cannot be in the green circle, they cannot be in the black circle. So the only other number that fits that description that does not lie in any of the three circles is 3. So there are 3 people who are men, unemployed, and also no college degree. Basically, they sit outside all 3 circles, which is why there are only 3 people that fit that description. Now, there's one question we can definitely answer, and that is, how many people were at the conference? We've sorted out the details, we have all the numbers. Every person sitting inside this rectangle is basically at the conference. So if we add all the numbers that we see inside the rectangle, including the 3, so what are the numbers we need to add? We need to add the 4 plus 20 plus 9 plus 16 plus 11 plus 8 plus 16. If we add all the numbers that we see inside the rectangle, we should get 77. So that's the total number of people that were at this conference. Okay, let's look at the next question. So in a trial of a new allergy medication, 120 people were given the medicine and 80 were given a placebo. Of those given medicine, 90 showed improvement in their allergies. Of those people who were given placebo, 20 did not show improvement. So let's think about this. We have different sets here. We have the set of people who took the medication, and the set of people who took basically a sugar pill, which is placebo. So there are 120 people who actually took the medication, and 80 people who took the placebo. Now, we have to think about how to represent this information. So let's look at the first possibility. Can we have a situation where we have overlapping sets of people who took medication and people who took placebo? Now, if you think about this, this does not work because a person who took placebo did not take the actual medicine, and a person who took the actual medicine did not take the placebo. So these two sets cannot be overlapping sets. So we rule out this possibility completely. Now let's look at the second possibility. Is this a possibility? So we draw a big circle for people who take the actual medication, allergy medication. Out of the people who actually took the medication, which is 120 people total, 90 showed improvement. So that's the reason why they're sitting inside the circle of people who actually took the medication. So 90 of those people showed improvement, which means the rest of them did not show any improvement. So they did take the medicine but did not show any improvement. So this seems like a clear representation of the information that is given. Now let's look at the other side, which is the placebo. So the total number of people who took placebo was 80, right? Now, of those people who took placebo, so within that set of people who took placebo, 20 showed improvement. And that it is clear, since there are 80 people sitting in the entire set of people who took placebo, 20 people improved, so we can assume that the rest of them, that is 60, showed no improvement. So the total number of people in that set is still 80. Now this looks like an okay representation, but somehow two separate circles almost seems like they're two different situations. So let's look at situation 3. So we have 3, and look at this representation. So basically, Venn diagrams, we can use any geometrical shape. So what we did here in this third possibility is we took this green triangle to be all the people who took the actual medication. This red triangle is all the people who took the placebo. And right in the middle, we have the people who showed improvement, and as you can see, that circle is partly lying inside the green triangle and partly lying inside the placebo triangle, which is the red triangle. So 90 people out of the 120, so the 90 out of the 120 showed improvement. The 20 out of the 60 who showed improvement in the placebo group. So this seems like a really nice representation of the information that has been given in that particular problem. This seems like good. This is okay. The second representation is okay. The first one is not correct. So I would say number 3 is the best possible representation of the information that has been given to us. Now, problem 7 is very similar to the previous problem that we just went over. So here we have cyclists who competed. All of them took a drug test, right? That's what the question says. So some of them tested positive, some of them tested negative. out of the people who tested positive, 3 finished in the top 10, and out of the, so there were 18 here, and out of the 25 people who tested negative, we can assume that 7 finished in the top 10. So again, it's very similar to the previous problem. So we could use triangles. Any shape works. So we use a triangle to represent the set of all people who showed positive. Let's say we use a blue triangle for the set of all people who tested negative. So out of the people who tested positive, 3 came out in the top 10. So there were 18 total in the people who tested positive. So let's put that in green. So there were a total of 18 people who tested positive. 3 came out in the top 10. So the middle circle represents the people who came in the top 10, who finished top 10. So 3 people out of the 18 who tested positive came out in the top 10, which means 15 people did not come out in the top 10. Now let's look at the other triangle, the blue triangle. Out of the 25 who tested negative, 7 came out in the top 10. So the rest of them, which is 18 of them, did not come in the top 10 people who finished. So when we add the two numbers sitting in the triangle, 7 plus 18 does add up to 25. So this is a good representation of all the information that is given in this particular problem.